This investigation seeks to find cup features that keep a drink cold. Features include things like materials, such as plastic, a coffee cup, metal, or possibly even styrofoam. It includes features like single walls, like this cup, double walls, like you can see in this cup, lids, or no lids. We could just blindly believe what other people say are the best features, or we can do an experiment to show if some features are actually better than others. Testing the claims and ideas and hypotheses of others may better help us draw good and even great conclusions that improve our lives. If someone does not test to see what is best, many people may make low quality choices and lose out on great options. Our focus question for this experiment is, what cup features seem most important for keeping a drink cold? To investigate wisely, we designed a fair test so that the features and variables of the cup system that stay the same include water temperature, time the temperature is measured, and the amount of water. We will test one feature at a time and record the measurements in a data table for future analysis. We'll start with the regular plastic cup, a single regular plastic cup, and a regular plastic cup with a lid, and a regular plastic cup making a double wall with a lid. Ultimately, this will help us to know if system features help keep liquid temperatures constant. As we begin with these experiments, we can see that our thermometers actually measure slightly different temperatures. One of them is 3 degrees off from the other temperatures at the same room temperature of air or of liquids. So this first thermometer, we're going to remember that it's 3 degrees low that we're putting into the first cup, 3 degrees lower than the other two thermometers. And what we'll do is we'll take the same temperature water. I have a jug of ice cold water, so you can hear the ice. And we're going to take the same water temperature as a starting temperature, and measure out 1 cup of water to go into each of our cups. And to make sure that we have the exact amount of water, we're measuring out the water with a measuring cup, and we'll pour it in, and it will take just a moment to get the thermometers adjusted to that water temperature. So we won't start our timer quite yet until all of our thermometers have a fair chance to adjust. So that we can take an initial reading. So we'll get an initial temperature, a starting temperature, and then we'll start the timer and see what happens over 15 minutes of time. Okay, again we have 8 ounces of water, of ice cold water. We'll pour it in. And as we get the water in there, we can see some changes already visually happening. What observations can you make about these changes? And what we're going to do is we're going to put the thermometer in with the lid on, second cup, and put the thermometer in the third cup, the double-walled cup. And then we're going to start off with some initial readings before we start our timer. And so let's check the temperature. Our setting, our temperature is -1 degree Celsius. And here on our second one we have about 2 degrees Celsius. And this one we have about 2 degrees Celsius. I'm going to start the timer here, and we're going to go 15 minutes of time. The starting temperature of the left thermometer is 3 degrees lower. So what does that actually mean? That means that all 3 cups, the thermometers are reading a starting temperature of 2 degrees Celsius. Let's see what happens after 15 minutes of time. Now that we're at 15 minutes, we are going to check the temperatures of all 3. So here we have 1 degree Celsius, and we add 3, so it is really 4 degrees Celsius. And this cup with the lid is at about 5 degrees Celsius. And this one is at about 5 degrees Celsius. So the cup with the double layers is at about 5 degrees. That one is at about 5 degrees. And this one was at about 4 degrees Celsius.